When we are looking at univariate data, it's more interesting to see a histogram. So then we use the hist function, and we can, for example, look at the histogram of the price, and it will be like this. Here you see that the default number format for R for large numbers is the engineering notation. So this is 1 times 10 to the power of 6, 2 times 10 to the power of 6, and so on. So here you would have 6 zeros after the 1, so it's 1 million, 2 million, 3 million, and so on. What we can do is we can use the options function, and we can use the science penalty, and for all numbers under 10 million, we would like to show all the digits. So for example, if we do this again, then we see the numbers themselves. But here we have 6 bins. If we would like to have more bins here, we could specify the number of breaks. So for example, we can look at the square meters, but the breaks should be 20, for example. So we should have 20 bins, and here we get it. Like the smaller apartments, we have 2 of them, and between 40 and about 50 we have, or 55, we have 3 in each bucket. So most of the data falls into the quite small apartment category, and we have some few large ones. And the point of a histogram is to see the distribution of your data, and if you have any gaps here. For example, we do not have any apartments from about 55 to 65. So what's that about? So you can, if you had a large data set and you have these gaps, then why do you have these gaps? You have to figure it out. And what we also can do is that we can put several histograms into one figure, and this method goes for all the plots. So for example, we can say the parameter, the MF row parameter, should be 2 rows and 1 column. So this will give you 2 rows and 1 column in one figure, which means that you can have 2 figures or 2 plots in one figure, one on top of the other. And this is excellent for comparing data. And for example, we have a histogram of the price, and here we only want the price for Oslo apartments. So here we have to say data city should be equal to Oslo. And of course we have to remember the comma. No, we don't need that actually, because we only have one column of data here. But breaks equals, let's say 10, let's say, and I remove this one, and main equals house prices in Oslo. So we know which it is which. X label is nothing. Then you just provide the empty string here if the X label should be nothing. And the color could be red, for example. So if we run that, then we see the house prices in Oslo. And if we make another plot here with Trondheim data, 10 breaks, and then of course we have to differ here, and we choose blue, then this histogram will be on the bottom. And here we could have, as you see that the histogram starts at 3 million for house prices in Oslo, and it starts at 1 million for house prices in Trondheim, then we could add the X limiter, and this, it should be like that, and this has a bottom and a top limit. So now it goes from 0 to 10 million. And we can do the same here. Xlim equals C 0 and 10 million. Okay. So if we just run this to get rid of that one, and of course we have to have the comma, and also when you program, you will always see these warnings, and here it actually told me that there is a missing comma. But if we now run by just Control Enter, we see that we can compare these distributions in a much better way because we have the same x-axis on both our histograms. So now we see that the house prices in Oslo in this dataset is higher in general than the house prices in Trondheim. So, and of course, when you're done with a plot, it's good practice to use the dev-off function to clean up the working space.